Hi, and this video is the normal distribution, which is a really, 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 really important distribution. It's your classic bell-shaped, symmetric distribution. This is an example. Uh, IQ is normally distributed with a mean of 100. So the mean and variance are the two parameters that define where it is and what it looks like. So here are four different normal functions. The mean of three of them is 0, and so three of them have the same central point, whereas the green one has a mean of -2, so it's over to the left. So the mean is the center of the graph, and the variance is a measure of how far spread apart the graph is. So the larger the variance you have, the lower and more spread out the graph is. And the smaller it is, conversely, the skinnier and higher up it goes. Okay, so the function for that kind of bell shape is actually incredibly complicated. And even if you're good at calculus, you just can't do it. There is no way to do it. And so what we have to rely on then is tables that were calculated by a computer to do any kind of area. And I'm going to teach you how to use these tables as well. So this table is called the Z table. And the Z is a special normal distribution. It has a mean of 0 and a standard deviation of 1. So also the variance equals 1 then. And the table tells us areas to the left of any given number. So let's say we're talking about the normal distribution of mean 0 and SD1, and I want for some reason to find the area to the left of 1.17. So I go to my Z table, and the numbers along the left are the whole number and the first decimal place. The numbers along the top are the second decimal place. So to find 1.17, I find 1.1 on the left, and then I find 0.07 on the top. These two combine to make 1.17, and the area then is 0.8790. So that's how you use the table. It gives you areas to the left of any given number. Okay, so generally you don't have Z in your problem. Like with the IQ, it wasn't a mean of 0, it was a mean of 100, and so on. So there's a simple way to go from the distribution that you have to the Z distribution. And it's a simple formula, and it looks like this. You subtract the mean, and then you divide by the standard deviation, and that makes Z. So let's actually use this. So we got height. Height is actually, in real life, normally distributed. And let's say it has a mean of 170 and a standard deviation of 12. So in that first box there, you see X is distributed as normal. Capital N means normal. And then you put the mean first. The mean is 170, and then the variance, comma the variance. The variance is 12 squared. All right, so the distribution looks something like this. It's got centered on around 170. And I want the area to the right of 180. That's the probability that somebody is taller than 180. Okay, so with my probability statement there, I'm on both sides of the inequality, I'm going to subtract the mean and divide by the standard deviation on both sides. On the left, that creates Z, and on the right side, the calculation gives me 0.83. So I want the area in the Z table to the right of 0.83. So I'm going to find 0.83, and that's an area of 0.7967. Okay, but remember, I don't want the area to the left, which is what the table gives me. I want the area to the right. So I have to subtract from 1 to give me the area to the right. This is a very common trick that we're going to do a lot. If you want the area to the right, the table will give you the area to the left, and you subtract that from 1. Okay, another example. So we have SAT scores, and these, again, are also in real life normally distributed with a mean of 500 and an SD of 90. Okay, so I want to find the probability that somebody scores greater than 400. Okay, we see a picture of it there. So on both sides, I'm going to subtract the mean and divide by the SD. So subtract 500, divide by 90. On the left side, that gives me Z. On the right side, that gives me negative 1.11. Okay, so it's a negative number. That's something we got to mention. The normal distribution is symmetric, so here's a really handy trick. The tails are exactly equal, so the area bigger than negative k is the same as the area less than positive k. So there's a picture of what it looks like, and you can see how the symmetry works, that those two areas are identical. So the area bigger than negative 1.11 is the area less than 1.11. And that's straight up, that's in the table without any manipulation. So I find 1.11, and the probability is 0.8665, and that's my answer. Okay, another example, back to IQ. And IQs in real life are normal, and they have a mean of 100 and a standard deviation of 15. Okay, I want the probability that someone has an IQ between 95 and 115. So with my probability statement, I'm going to, in all three places, I'm going to subtract the mean and divide by the SD. And in the middle, that creates Z. On the left, it's negative 0.33, and on the right, it's 1. So if you can remember the trick that I used with the exponential distribution in the last video, I'm going to do the same thing here. I'm going to find the area to the left of 1, and then subtract the area to the left of negative 0.33, and what's left over is the area between. And notice as well that in the X distribution, the area to the left of 115 is the same in the Z distribution as the area to the left of 1. So these two statements are exactly identical. Whether I'm talking about X or talking about Z, it's the same thing. Okay, so to the Z table. So the area to the left of 1, so 1.00, is 0.8413. And the area to the left of negative 0.33, so from the same trick as the example before, I'm going to look up 0.33 and do 1 minus that area. That'll be the area to the left of negative 0.33. It's the area to the right of positive 0.33. And we get the answer of 0.4706. Okay, so that's how you do probabilities between two numbers. All right, so let's say newborn baby weights are normally distributed with a mean of 3.6 and a standard deviation of 0.2. Let's do something about percentile. So I want to find the 15th percentile, which is a number W such that 85% of babies weigh more than W. So the picture looks like this. So there's a number W that we can find such that the area to the right of W is 0.85. So to manage this, we have to go to the table and search around the middle, try to find the closest number to 0.85. And that happens here at z equals 1.04. So we have to find the z number first. So, and actually, it's not going to be 1.04. It's going to be negative 1.04. So I want the area to the right to equal 0.85. So now that I know that z is negative 1.04, I'm going to work backwards to find x. So this is the formula. If I plug in an x, it gives me a z. If you do a little algebra and solve that for x, we get this. So plug in the mean, the SD, and z, and x equals 3.392. So that is w. That's the number such that the area to the right of that is 0.85. So that's how you do percentiles. You have to look around in the middle of the table to try to find that area, or as close as you can to that area, and then that gives you z, and you plug in z to find x. Okay, so that's the basic skills you need with the normal distribution. And again, we're going to be using them a lot. So that's a taste of things to come. And we'll practice this more in class as well. I'll see you there.